Yes, I'll take 2, 4. Can you hear me? Thank you. All right, so if anybody has 2, 4, you want to give it to me? Give it to me. I have a couple people from period 5 and period 4 up here. Okay? Okay. So here's the deal. If we can get through these slides, you're going to have 10, 15 minutes at the end to work. We left off with this one. We were finding the zeros, correct? Correct? Okay, so when we found them yesterday, whoops, we used a method. What was the method? Uh-oh. Not here. What was the method to find your zeros yesterday? P's over Q's will get you rational zeros. Now, rational zeros are fractions, so it could be 6 over 1. It could be 2/3. It could be 1/2. But basically, rational zeros is what we're testing for. Okay, so it's P's over Q's. There you go.
That's funny. This piece of paper was here.
Yeah, but really, you can just leave your bottle on the floor.
It fell out of my backpack.
It's like 2 lies.
I didn't know I left it.
Why do you have your phone in your hand?
You can have your phone all the way.
Well,
what?
Hurry up, pick it up. Go. Throw my glass down. Let's go. You can't be that thirsty. Put it there. All right, see you go. Get your homework done. Okay, P's over Q's. Okay, what were the P's? The P's. Factors of constant. Okay, so factors of the constant are right here. What? 2, 4, 8. Okay, boom, boom, boom. Okay, over. What are Q's? But factors of leading coefficient, which is 1. So I want the zeros. Okay? Okay. Now you should be able to tell me right now when I say plus or minus 1 down here, the possibilities are just these, right? Go find them. Go get your zeros. How are you going to do it, guys? Synthetic division. Just think like you're going to divide. And you know if it's a 0, the remainder is 0, right? Okay? Now there's a bad thing about this. There's actually 2, 4, 6, 8 choices. Maybe we can go fast. Maybe as soon as somebody finds one, just say it. Okay? And we'll all work together. Well, you can start with anything, but I would start with 1. And then go to -1. Then 2. +4. 4 works. Did you try it?
I did.
Okay. All right. Sylvester says 4 works, right?
I think so.
4 works. Okay, let's try it. I got a 1. I got no x cubed. I got -2.
Oh, I forgot.
I got 0 here and -8. Now you tell me it doesn't work.
No.
Okay.
2 works. 2 works though.
2 works. Okay. Everett says 2 works. Okay, I'll try 2. 0 here. Bring down to 1. Multiply 2, add down 2, multiply 4, add down 2, multiply 4, add down 4, multiply 8. It worked. So one of my zeros is 2. Got it. Hey, just a question. How many zeros are there?
4.
4. Because of this 4, you know there are what? There's 4 zeros. Okay, we found one of the 4. Okay? All right, we're going to find another one. So 2 works. Now, you guys, when you get to this point right here, 1, 2, 2, 4, don't go back up here. Stay with the smaller polynomial. Gavin, you look like you're relaxed. What's the other 0? You're so relaxed, you must have it. John.
I can
Guys,
tell
you
when
guys
it's
look
not.
so relaxed. It's like you're waiting for other people to do
I
your
can tell
work.
you that it's none of the eights.
Yeah, it's not -4.
It's not -4.
It's not 4 either.
-2. Okay. All right, let's try it. -2. Let's hope they're right. Put a 0 here. 1, this and this, -2. Add down 0, multiply 0. Add down 2, multiply -4. You did get 0. Good. Okay. 2 works, -2 works. They are zeros, but now you got 3 numbers in the end. And when you have 3 numbers in the end with a remainder of 0, yes, this was a 0, because what you actually did is this. You divided by what? When you put the 2 there, you were dividing by x minus 2. When you put the -2 there, you were dividing by x plus 2. When you do all this division, these 3 numbers, that's the answer. So this is x what? X squared minus 2. Good. And you know the other factors were x minus 2, x plus 2, right? Okay. Now when you get to the last factor, it's quadratic. In quadratics, they should be easy for you to solve. So you see how you're going to do it.
Shouldn't it be plus 2? X squared plus 2.
Yes, you're right. She's right. Plus, it's right here. Positive 2. Okay. How are you going to solve that last factor? Set it equal to 0. Good. Okay. When is this plus this 0? Well, slide the 2 over, make it negative. Take the square root. Take the square root. Answer?
Plus minus I squared.
Plus or minus I square root of 2, says Aaron, and he's right. And of course, this 0 and this 0 were what? Plus or minus 2. So did I find 4 zeros? Yeah, I did. Okay. Synthetic. P's over Q's, synthetic division. Keep going until you end up with how many numbers? How many numbers are on the bottom? 3. When you end up with 3 numbers on the bottom, you have a quadratic factor. Quadratic factors, you can use the formula, you can factor it, or you can solve it. This one I solved, because I couldn't factor, and I did not want to use the quadratic formula. Okay? All right. Now, here's the deal. Write this word. Write that word next to that slide somewhere. Or you could have solved it. And by the way, I don't remember it, so help me out.
X to the 4th minus 2x squared
Okay.
minus 8.
Minus 8. Okay. Or you could have solved it a different way. You did not have to use P's over Q's. You don't have to. How else could you do it?
Could just plug them all in.
You what?
Could just plug them all in.
Plug them all in.
Be long, wouldn't it?
Oh, I see what you're saying. You're saying plug all the P's and Q's in.
Yeah.
But I'm saying you don't have to do P's over Q's.
Is it factorable?
Oh, what?
Is it factorable?
Is it factorable? Are you guys looking at this? How many terms do you see? 3 terms. It's called a what? Trinomial. Doesn't this kind of look like this? It has the same look as this problem that you did in 9th grade. How would you factor that? X minus 4 times x what? Plus 2. If you FOIL this out, do you get this? Is -4 times 2 -8? Yeah. Is -4 plus 2 -2? Yeah. Oh, well, guess what? That has the same look. But there's something weird about it. It's not x squared, it's x what? It's x to the 4th. Big deal. Just do it. Try it. Just try it. What would it have to be here, guys? What would this have to be?
X squared minus 4.
X squared times
X squared
x squared. Is that x to the fourth? Yeah. Now guys, this is the same thing. Give me two numbers, multiply, we'll give you that. Add them up, you get negative 2. It's got to be the same numbers. Minus 4 plus 2. I have two factors. Both of them are quadratic. How do you want me to solve these? Are either one of them still factorable?
Yeah.
Which one's factorable? The left one? Okay, so this is just what? X plus 2 times x minus 2, because it's the difference of two perfect squares. This one, not factorable, because it's not the difference of two perfect squares. There's no GCF. There's nothing for me to do. So what do you do on this one again? CC kind of said it already. Just do what? Set it equal to 0. When is x squared plus 2 going to be 0? I could do the formula, but no way. I'm not doing it. Right? Square root, and you end up with x equals what? Plus or minus I squared of 2. Look at that. There's your zeros. And out of this one and this one, there's your zeros. Right? Which method do you like better? P over Q. I was trying to get you to say the other one. You really like that other method better? I always think factoring is my best friend.
Same.
Really?
I think it's nice and
I think factoring is so easy. If you guys can factor, you can pull out the zeros so quick. Versus synthetic and work it out. Synthetic, work it out. I mean, this seems so much easier. To me, it does. But whatever. You make up your mind. I just wanted to show you there's two different ways you can go about it. Okay. All right. All right. Here we go. Next problem. Graph this function with your calculator and then tell me how many rational zeros does it have? How many real zeros does it have? Okay. I'm going to do it on a standard window, 10, 10, 10, 10. Okay. I do need to look at somebody's. No, so I can copy it. Yeah.
Oh, I'm in, I guess.
Okay, go Zoom 6 or something.
Sorry, I just.
very interesting.
Oh, because you wanted to see the zeros better. Now, on this calculator, on Lauren's calculator, it goes like this. Comes down, there's a little wiggle, comes this way, leaves the screen, and then all of a sudden, kind of comes up like that. Okay?
It comes straight up.
Okay, now, here's the deal. Do you guys know anything about this? About this polynomial? Just look here. It's x to the fourth.
4 zeros.
Well, okay, 4 zeros, okay, gotcha, but I'm talking about the graph. I'm talking about what does the graph do? Think end behavior. Up, up. It's positive x to the fourth. It acts like a parabola, up, up. So really the arrows are right here. There's the arrow. There's the arrow. Now what's it doing down here? I have no idea. I'll just do that, okay? I have no idea. I'd have to open the window bigger, but I don't care because I'm looking for zeros. My zeros are here and here. How many rational zeros does it have? Rational means fractions. If you really kind of do zoom in on this, if you want to shave off a few of these x's and shave off a few of these, you could probably see it better. But can you tell right now what they are? No? Okay, then go to your window and shave off a couple x's. Don't go 10 out and 10 back. Go maybe cut it down to 5. Something. Yeah, I don't know. I think 5 might be a little too
5's too much. Right?
too much. Is that what it is? Okay, -1 and 6, right? Okay, so if you kind of zoom in a little better, you know, shape your window a little smaller, you can see those are your zeros. So how many rational zeros do I have? By the way, 6 is a fraction, -1 is a fraction. How many do I have? 2. Okay. How many real zeros do I have? Real is everything except imaginary. Aren't those real numbers? 2. Okay, I have 2 reals because they're both rational. So it's 2 and 2. Okay, now use synthetic factoring and your knowledge of quadratics to find the remaining, how many? 2 complex zeros. How did they know it was complex? How do they know the other zeros are complex? Here's why. Because real zeros are visible. They're visible on your calculator. You guys, can you see your real zeros? Sure you can. The ones you can't see are what? Imaginary. So the other 2 zeros have to be imaginary. And that's why they said go find them. Go find the other 2 imaginary zeros. Okay, well let's get started. You guys have to help me out because I can't remember those coefficients. Here we go. 1 what? Ooh, 1.
-2.
Okay.
-18.
And what?
18.
18. Okay, and we know what's a 0? -1 and 6. Okay, I'm going to start with a little number. Here I go. I feel like you guys should be ahead of me. I shouldn't be showing you all this. Go. Hurry up. Try to get there. Once you get it, do it again. The next time you do it, do a 6. I got a -1 to work. So I know -1 is for sure a 0. I got to try the 6. Put the 0 here. Bring down the 1. I got 6 to work. I hope I'm not showing you the answer. I hope you're actually you're ahead of me. Okay, so now I got to 3 numbers. 1, 2, 3 numbers. Now, if you get to 3 numbers, all you have left is a quadratic factor. So you have to realize this was like dividing by x plus 1. This is the same as dividing by x minus 6. What's left? The answer to your division. You were actually dividing by this, weren't you? When you did this? Here you were dividing by x plus 1. This is what's left. What is it? Okay.
3x plus 3.
Plus 3x plus 3. Okay. Do you guys remember how I said factoring is my best friend? Well, guess what? If these are imaginary zeros, you can't factor. You can't factor that. So how are you going to solve it? Probably the formula. Okay? Go do it. You should know when you're done, I is going to be in your answer. Hardest part of quadratic formula, don't get the number wrong when it's inside the radical. Jeff, what'd you get inside here? You got -3. Yes, no? Yeah, okay. Really quick, guys. That is 9. Negative times positive is negative. 4 times 1 times 3 is 12. That's where Jeff got the -3 from. That's good. What's the square root of -3 though? I square root of 3, right? Oh, how many zeros do you see here, by the way? 2. -3 plus this and -3 minus this over 2. So there are 2 zeros here. I'll write them out for you just so you can see them. First one is this. Second one is this. Okay, so here are your other 2 zeros. What do I really want you to know about imaginary zeros? Do they show up on your calculator? No, they don't show up. You might say there's no zeros. No, you're not right. There's imaginary zeros. They're out there, guys. You gotta find them. Okay? Typically, what finds them for you? The quadratic formula. Unless you're lucky enough to just set it equal to 0 and solve it, which you sometimes are lucky enough to do that. Good? Nobody has a hand up. Let's go. Oh, okay, look at this. Here's a statement they make to you, and they're telling you this. If your function f is a polynomial with real coefficients, and a plus bi is a what? Is a 0. If a plus bi is a 0 of your function, then this is also true, guys. A minus bi is also a 0. So what are they telling you? If you know you have a 0 that's imaginary, you have another 0. What is it?
Opposite.
Not opposite, it's conjugate. I get what you're saying when you say opposite, but if I told you this, 6 minus I is a 0, you should say, so is what? 6 plus I. That's what you should be thinking. And I can prove it. Well, I don't have to prove it to you because look, it's right here, isn't it? Didn't we just do this? Look at that. -3 plus I squared root of 3, -3 minus I squared root of 3. They come in conjugate pairs, okay? That's what they always do. All right, let's do this one. If 3i is a 0 of this polynomial, what are the other 2 zeros? So, I know 3i is a 0. What are the other 2 zeros? There's 2 more, guys. Anybody know? -3i, the conjugate pair, yes. Yes, okay, so you got one of them. Now what do I do to get the third one?
Synthetic.
What?
Synthetic doing.
Why not? We've been doing it all day yesterday. Why wouldn't we do it today? So, Hunter, 3i is a 0. What do I do? You said it. You have to follow up and tell me what to do.
Find the P's and Q's.
I don't have to. You know the 0 is what?
3i.
So why would, if you know that's a 0, why wouldn't you go like this? Why wouldn't you just do that right now? If somebody tells me I have a 0, it's 3i, I'll put 3i there. I know I'm going to get 0. So put the coefficients up here. 1, -3, 9, -27. Start. This is not easy, just so you know. Let's see what you get. Eddie. Let's go. Come on. Okay, so I did the easy one. 0 plus 1, 1. Now what? What's this? 3i times 1. 3i. Okay, that wasn't the hard part. Here comes the hard part. When you add, what do you get? Are these like terms? No, don't you dare add them. They're not like terms. It's negative 3 plus 3i. Yeah? Okay, now what?
Then you get negative 9i plus
Okay.
9i.
So you're multiplying, aren't you?
Yeah.
Yeah, that times that is negative 9i.
Plus 9 squared.
And then 3i times 3i is 9i squared. But then you have to think about 9i squared. What is 9i squared?
Negative 9.
Negative 9. Okay. Cross it out. Just put negative 9. Now what's 9 plus negative 9i plus negative 9? Don't these 9s just
Negative 9i.
go away? Okay, there you go. What's 3i times negative 9i? Negative 27i what? Squared. And then you just basically change that to what? Positive 27? Which makes 0. It works. It should work. Why should it work? Because they told you it's a 0. It should work, okay? But wait a minute. Then Hunter said, I think Hunter said this, so is negative 3i. Oh, well, if negative 3i is a 0, I might as well do that one too. Here we go. Put a 0 here, bring down the 1, start. You know how to do it now. Oh, go get that other 0. Negative 3i times 1 is negative 3i. Add this to this and get what? Negative 3, yeah. Okay. Now, negative 3i times negative 3 is 9i. There you go. Negative 9i on top of positive 9i makes what? 0. We got it. We got it, guys. Good job. Now, remember, there's 3 zeros. Where's the other 0? It's right there. This creates your last factor. It will be x minus 3. Just a quick question. What were your other 2 factors again?
3i.
Well, no, 3i was a 0, but that came from what factor? X minus 3i. Negative 3i was a 0. That came from what? X plus 3i. Okay, so these are factors because they gave me the zeros. What's your last 0? X equals 3. This 0 and this 0, they were plus or minus 3i, weren't they? So there's my zeros. Good? I'm moving on. You guys are saying it. Hunter, say it again.
What?
Question?
No, I was just clarifying.
Okay. All right. I'll move on. Okay. Here we go. Now something comes at you that this is kind of like, this is just extra information about a polynomial. You know that information I gave you way back in 2.2? Remember end behavior stuff? Guys, tell me what this does. What is this? Up, up? You guys agree that it's up, up? Because it's even, acts like a parabola, up, up, or down, down. Because it's positive 6, you're going to say what? Up, up. Okay. Well, that's just good information to have about a polynomial. Well, here's more good information. It's called Descartes' rule. And here's what it says. Let f of x be a polynomial function where the constant term, right here, guys, the constant term is what? Not 0. Well, that's not 0. Hey, it works. I can do Descartes' rule. Well, let's take a look. Part A. Here's part A. The number of positive real zeros. So it's telling you what? How many what? How many positive real zeros does this thing have? Well, of your function f is either equal to the number of variations in sine of f. That's kind of weird. The number of variations of sines. Here's what they're saying. Look up there. This is positive. What's the next one? So did it change signs? Yes, it did. 1. Negative goes to what? Did it change signs? Yeah. Positive goes to positive. Did it change signs? No. Positive goes to negative. Did it change signs? Yeah. So, see that number? 3. The number of positive real zeros, how many? 3 positive zeros. It could have. Or, if it doesn't have 3 positives, guess what it's going to have? An even number less than that number. Don't say 2. What they're saying is, when they say less than, they need to subtract. Subtract 2. 3 or what? 1. So the rule, it just keeps subtracting 2 until you get down to 0. Okay? So it could have 3 positive real zeros, or it could have 1. Okay? That's it. That's all it is. Here's this one is a little harder. Yes.
So what if it was like 5?
Oh, okay. So he says, and this is what Harry says. What if it's 5? Well, then it's 5 positive reals, or 3, or 1. It's always minus 2. Minus 2. Okay. Next. Well, if I have a rule for positive real zeros, I got to have a rule for what? How many negative real zeros could this polynomial have? This one you have to work at. I'll show you. This one says is either equal to the number of variations in the sign for what? What does that say? If you want to know negative real zeros, you got to plug in what? F of negative x. So I got to go up here and do the work. So be careful when you do this one. This one says 6 times negative x to the what? 4th. Then what? Minus 4 negative x to the what? 3rd plus 5 negative x squared plus 2 negative x minus 24. Okay? Do the work. Here we go. Negative x to the 4th is going to end up being what? Positive x to the 4th. Times 6. Okay, so it's 6x to the 4th. Negative x, cube it. What do you get? Negative x cubed times negative 4. Positive x cubed. Negative x squared is what? Positive x squared times 5. 2 times negative x. There you go. You just did f of negative x. Now, talk about the variation of sign. Ready? Positive goes to positive, doesn't count. Positive goes to positive, doesn't count. Positive goes to negative. There could be 1 negative 0. Negative goes to negative, doesn't count. So what's the answer? How many negative real zeros? 1. Now, if you subtract 2, you're in the negative, so don't do it. That's it. 1 negative 0. There could be 1 negative, but there could be 3 or 1 what? Positive. Now, just so you know this, what that is, it's just helping you understand the polynomial. That's all it is. Like end behavior is nice because it right away when I see it, I go like this. Oh, this polynomial goes up. Oh, cool. It's not up. But this thing tells me what? Just all it tells me is, there might be 3 or 1 positive zeros, or there might be 1 negative. That's all it's telling me. Most of you care or don't care. Most of you care about that, or you don't care? Alec, he's already saying it. I don't really care. I don't care. You know what I'm going to do if you tell me to find the zeros? I'm going to do my P's over Q's, and I'll find those zeros. Most of you won't care about this. This is just something that they're telling you. This is extra information about your polynomial. And most of you could care less. I'll go find them anyways. Well, whatever. If there's 2, 3, 4, I don't care. I'll get them. But it is cool. It tells you how many there are. Okay? Here's a summary of what we talked about yesterday, today. I'll go quick. Here it comes. We are finding what kind of zeros? Complex. What's complex? Could be rational. Could be real. Could be imaginary. Okay? That's what you're doing. Okay, here's how you do it. You compile a list of possible rational zeros. How do you do that? P's over what? Q's. That's how you do it. I'm trying to tell you, every time you do a problem, do this stuff. Once you get the P's over Q's, then maybe graph the function, and when allowed, what I mean by when allowed, if I allow you to use your calculator and say, use your calculator to find some of the zeros, that helps. To determine the rational zeros. So the calculator helps. It will tell you what they are. Use synthetic division. Once you know what you're going after, use synthetic division to factor the polynomial into linear factors. Now what's a linear factor? Can anybody give me a linear factor? X minus 2. X plus 4. Get a bunch of linear factors, and then the last one will be what factor? The last one, when you're almost done, will be quadratic. Give me quadratic. X squared plus 6. There you go. There. So you get it down to the last factor, quadratic, and then you set the quadratic factor equal to what? Set the factor equal to 0, and then solve it. How do you solve it? You factor it. You use the quadratic formula. Maybe you just solve it. I don't know. And you're going to get this. Rational, real, or complex zeros. And then, of course, you got to list all your zeros in the end, and then you're done. There. That's what you've been doing for a day and a half. And now, here comes your last problem. Do it. I'll just check it. See what you're doing.
I didn't find out how many zeros there are.
Are you just looking at highest power?
Yeah.
So like that one?
It's 4.
4 zeros.
Alright, so I'm just
Sometimes they're going to be,
all of them will be rational.
some will be real, some will
Obviously, I forgot how to find how many zeros there are.
That's it. You guys know that there's 4 zeros, right? What is 4 plus
Oh, yeah, I saw this.
Yeah, swap.
2x minus 2.
Oh, what's square root of 1? So isn't 1 times I just I?
Yeah.
It's just right. Are you factors x squared? Oh, minus 4? Okay. Yeah, something's wrong there. I mean, slightly wrong. Did you? All right, let's see it. Who did it? Who did the P's and Q method? Raise your hand. P's and Q's. 1, 2, 3. Hunter. Oh, you
I
factored?
did do P's and Q's.
Yeah, I saw you doing P's and Q's. Okay, I saw 5 or 6 of you doing P's and Q's. When it works, it works. It's just that what's faster? Factoring's faster. If you did factor this, guys, you got what?
X squared minus 4.
Okay.
X squared plus 1.
Okay. And then this is so nice because you can just set them equal to 0 and do what? Solve them. Okay, this one's going to be easy for you because it's just x squared equals 4, or better yet, x equals what? Plus or minus 2. That's an easy one. The other one, not quite as easy. It's going to be x squared equals negative 1, square root of this, x equals plus or minus I. There it is. Much faster than P's and Q's. P's and Q's, if you did this, you probably figured this out, right? These are your choices. You have 6 choices. If you did it this way, you probably found 2 works. But this is tricky because it's 1, 0, negative 3, 0, negative 4. And I tell you what, those zeros make it hard. They just do. I mean, I can do this fairly quick for you. This is 4, this is 1, this is 2, this is 2, this is 4. So that works. I also know negative 2 works because I can cheat now. I see it. Put a 0 here, I get 1, multiply this, add, I get 0, multiply 0, 1, multiply, negative 2. It works. Are you guys seeing what I see? 1, 0, 1 is what? X squared plus 1. Hey, look at that. Isn't that that? Yeah? Hey, it works either way, guys. It doesn't matter how you do it. You're still going to get plus or minus what? I. And then here's your other zeros, 2 and negative 2. But no matter how you do it, you get the same answers. How many people like to factor? Would rather factor? I just feel like as you guys have learned it, why don't you use it? I mean, P's and Q's, I only do it because I can't what? Factor. I can't factor it. I can't. That's why I do it. But once I get it down small enough, 3 numbers, then I just factor, I do the quadratic formula. Okay? I'm done. That's it. So you don't have much time. I'm sorry. Was there anybody out there that wanted to hand it to 4? I think some of you already did. Hunter, yours is in. But that's it. Let me read you some names of people that should be giving it to you. Chloe, Everett, 2424, did not make it in.